All right, 13.3 measures of relative position. Okay, we start off with z-scores. All right, so your z-scores are going to represent the number of standard deviations that a data value is above or below the mean. So if it's above the mean, then your value will be positive. If it's below the mean, then your z value, or z-score, I should say, would be negative. No, I'm just writing. Yeah, I'm about to explain in a second. Thanks for checking though. No, can you hear me now? Testing, testing, one, two, one, one. Uh, testing, testing, one, two, one, two. Can you hear me? Yes, not. Maybe. Can anybody else hear me? Guess that's the question. Let's see. I'm going to leave and come back, see if it works. Okay, somebody said, okay. Thank you for letting me know that you can hear me, Ms. Sullivan. Appreciate that. All right, so I'll go back. All right, so when it comes to your formula, remember we talked about last class? I think it was last class. If not, it was a class before last. That your notation is going to matter, and you will have different symbols depending on whether you have the population or the sample. So here for the population symbolism, you have your data value, which is x minus the population mean or the standard deviation. Same thing with the sample, your data value minus your mean over standard deviation. And so generally this is the formula that we're talking about here. Whether you're dealing with the population or your, okay, great, great. I'm glad you can hear it now. Thank you. Whether you're dealing with the population or the sample, the formula is always your data value minus the mean over your standard deviation. So like I said, when it's population or sample, you will use different symbols, but the general formula is your data value minus your mean divided by your standard deviation. All right, so we have Raul has taken two tests. He scored 70 on the first test, for which the mean of all scores was 65, and the standard deviation, I just wrote SD for standard deviation, was 8. He received a 60 on the second test, for which the mean of all scores was 45, and the standard deviation was 12. In comparison to the other students, did Raul do better on the first test or the second test? All right, so the first thing we can do is look at the first test and gather the information for the first test. So he scored a 70 on that first test. The mean was 65. Standard deviation was 8. Let's see. Say he scored a 70. Book had 72. I'm going to change that to a 72 just in case they have a 72 for a particular reason. So change that to a 72. He scored a 72 on the first test instead of a 70, just in case they have a 72 for a reason. All right. So to find the z-score, we're going to do 72 minus 65 divided by 8. 3.875. So for the second test, he scored a 60. The mean was 45, standard deviation was 12. All right, so in the second test, he scored a 60, but the average of the class was 45, and standard deviation was 12. So 60 minus 45 divided by 12. And remember the symbolism here, I use sample. I didn't have to, I could use population, but remember it doesn't matter. What it is that you looking at the data value minus the mean over the standard deviation. So that's all that matters when it comes to your z-scores, that you remember that relationship. It's your data value minus the mean over the standard deviation. Questions before we come to our conclusion? So looking at what he did on the first test, all right. So that's how we would interpret the information that we received, or the information we calculated. On the first test, he scored 0.875 standard deviations above the mean. On the second test, he scored 1.25 standard deviations above the mean. Forget, because the value is positive, it means that's above the mean. If it was a negative value, if your z-score was negative, that means it would be below the mean. So in comparison to his classmates, he did better on the second test. Even though he scored a 60 on the second test, in comparison to that 72 on the first test, what we're talking about in comparison to his classmates. All right, any questions? All right. All right, so a consumer group tested a sample of 100 light bulbs. It found that the mean life expectancy of the bulbs was 842 hours, with standard deviation of 90. One particular bulb company had a z-score of 1.2. What was the lifespan of this bulb? All right. So as always, you write down your given information to figure out what it is you need to figure out. So it says our mean is 84 point, well, 842, standard deviation is 90. And it actually had a z-score of 1.2. So what's missing is the data value that represents this light bulb. All right, the lifespan of the light bulb. So that's our X value, the data value that represents the actual light bulb. So we're gonna have to solve. So don't forget how your formula is set up. Once again, is your z value is equal to data value minus the mean over the standard deviation. So we really could go ahead and solve it before we actually plug in values. It's up to you. If you want to plug in the values and then solve, or solve it first. Um, uh, I'll just plug in the values. So that's 1.2 equal to x, which is what we want to find out, minus 842 over 90. So first thing we'll do is multiply both sides by the 90. Nineties cancel out on the right. So it's 108 x minus 842. Then we add 842 to both sides. The 842's cancel on the right. X is going to be equal to 950. So the light bulb has a life expectancy of 950 hours. All right. Questions? Any questions? All right, so the pth percentile, that's the percentage of data that is less than the given value. So we had just a quick example. The baby's weight is in the 85th percentile of the U.S. So when you take a baby in, they always measure it, or when it's born, it's measured. So it's in the 85th percentile. This baby is. So that means 85% of the babies in the U.S. weigh less than this baby, and 15% of the babies in the U.S. will weigh more than this baby. So that's what it means to be in the whatever percentile. All right, trying to find a decent example for this. Hold on one second. Okay, let's go here. All right, so the percentile of a given value. In order to find the percentile of a given value, we would take the number of data values less than x, or less than that given value, divided by the total number of data values, and then multiply that by 100. So we want to find a percentile, take the total number of data values that are less than the value you're talking about, divided by the total number of data values given, then multiply by 100. Where the score of So on an exam given to 900 students, Elaine's score of 602 was higher than the scores of 576 of the students who took the exam. What is the percentile? And I looked up and see percentile for her score. All right, so she scored higher than 576 of the students. Totally, there were 900 students who took the test. And we're going to multiply it by 100. So remember, your top number is how many data values that are less than 602. Her score was 602. So we're looking at the number of data values that was less than 602. And here total. And here we have the total number of data values on bottom. And you just multiply that by 100. And we should get 64. So her score of 602 places her at the 64th percentile. All right. So this is a good place to stop. We still have one or two more things still to talk about in 13.3, but we only have 3 minutes left as far as getting to 8:50. So like I said, this is a good place to stop. So questions, concerns, or comments before we close out today? Everybody good? Everybody straight? Okay. So we will call it a day. We'll pick up right here on next class, finishing off 13.3 and then possibly getting into 13.4. So outside of that, you guys have a great day. Be safe, and I will see you on Wednesday.